Hello student, welcome to the live session. This is the third live session of this particular course, Optimization Methods for Civil Engineering. So today we will discuss, we received some queries from you related to mainly related to MATLAB code and R code. So we'll discuss those questions initially, and then if you have any other question that we'll discuss. Yeah. So first question that is related to multimodal function. So when we have discussed application of genetic algorithm on multimodal function, and then we also discuss about how to select the mutation probability. Okay, so somewhere I discussed that mutation probability should be 1 by the
Yeah, for hang on, look.
So there are some technical problems. So let us start from the beginning. So in this particular live session, so I will mainly discuss about a few questions that I have received related to MATLAB code and R code. So that I will discuss, and also related to some genetic algorithm and that basically I will discuss in this particular class. Okay, so let me go to the first question. The first question is related to the mutation probability that we consider in case of genetic algorithm. So I say that, so in case of binary coded GA, suppose let me take a string. Okay, suppose the binary bits. So this will be either 0 and 1. Okay, so this is the random bit I have considered here. Now I would like to apply mutation here. So what I will do basically, so I said that you consider a mutation probability which is equal to 1 by L. So L is the string length. So in this case, this is 1, 2, 3, 4, 5, 6, 7. So this is I am considering L equal to 1. L is 7. So mutation probability is 1 by 7. So idea is that, so when you are considering a mutation probability of 1 by 7, that means the one of these 7 bits will be mutated. Okay, so one of them will be mutated. So this is on an probabilistic approach. So you will basically mutate only one bit. So what I will do basically, so I will suppose you are initially at this particular bit, and you will generate a random number. Suppose this random number is greater than equal to 1 by 7. So in that case, what I will do, I will not mutate. Then I will go to the next bit. So if it is again greater than equal to 1 by 7, then I will not mutate. Go to next bit. So if it is greater than equal, then you will not mutate. But when it is less than equal to 1 by 7, so then I will mutate that one. Okay, so that way I will go to the next bits, I will go to the next bit, and I will go to the next bit. So that way I will consider, I will complete one string. So that means that out of the 7 bits, 1 bit will be mutated. So we should consider a low value of mutation probability. So as I said that it should be very low value. So ideally I can consider 1 by 7. That means 1 bit out of 7 will be mutated. Okay, so you can also consider other, suppose this is the thumb rule, but you can consider a mutation probability of 0.01. This is also fine, or you can also consider 1% or 2%. That is also fine. So I hope I could clarify your doubts, so that way I can implement the mutation probability. Now let us go to the next question. So next question is how to calculate dij value. So that actually one student has asked. So this is in case of multimodal function. So when I have discussed a multimodal function, that means the genetic algorithm has the capability to capture all the local as well as global optimal solution of a problem. So they are actually, so we consider the crowding distance, and in order to calculate crowding distance, so we need to calculate dij. So one student is asking that how to calculate this dij. So that is basically the Euclidean distance. Okay, so let me explain that one. So I actually use this Dij when I have discussed the sharing function concept. So this is sharing function concept, and this is the Dij, that is the distance between two solutions. So if Dij is less than sigma, sigma is a user defined parameter. If Dij is less than sigma, so in that case, as its value is calculated 1 minus Dij by sigma, otherwise it will be equal to 0. So now I am not explaining this part, so because the question is how to calculate Dij. So let me explain that one. Okay. Now this is the example problem I have considered. So in this particular problem, so I have total 6 string. Okay, so I have total 6 solutions, that is 1 2 3 4 5 6, and these are the strings. This is first, second, third, fourth, fifth, and sixth, and this is the decoded value, and I consider what is the value of x. Okay, and this is a single variable problem. So this is a single variable problem. This function we have only x. Okay, so this is a single variable problem. And so I calculated what is the value of x, okay, and what is the value of x for the solution 1, then solution 2, solution 3, up to solution your 6. Okay, so that I have calculated. Anyway, I also need the function value, so I calculated, because this function value I have considered as a fitness value. Now how to calculate the distance? So distance is, suppose I have created this particular table. So this is solution 1, solution 2, solution 3, solution 4, up to solution 6, and on this particular row also. So this is 1 2 3 4 5 6. Now Dij, that is this is your distance between 1 and 1. That means the distance of solution 1 from solution 1. So that is distance is 0, because this is the same solution. Now for the other solution, okay, so you calculate distance, that is Dij, which is equal to, so I can calculate, suppose this is, in this case we have only one variable, so that is suppose this is the first solution and this is the second solution, distance between first and second solution, and then square. Okay, so in this case this is the, because this is a one variable problem, so this is x1 minus x2. But if you have more than one variable, suppose Dij, so you have two variable, that in that case what will happen, this is x1 minus x2 whole square plus y1 minus y2 whole square. Okay, so this is the distance, Euclidean distance, so you are calculating. So here this is the distance, so that is solution distance of solution 1 from solution 2, that is this is D12, that is 0.127, and this is 0.365, and this is also distance of distance of solution 2 from solution 1. So therefore this particular value and this particular value is equal. So you just see this is 2 1 and this value is also 2 1. So and 1 1, D11, D22, D23, so these are all 0 basically, because this is the distance of that particular solution from that particular solution itself. So that diagonal values are your 0. Okay, and this is a symmetric matrix. Okay, so I hope this is clear how you will calculate the distance. So once you are calculating the distance, then you calculate the niche count value, sharing function value, and after that you calculate the niche count, and then you calculate the modified fitness value. I hope this is clear. So I can calculate the distance, and then I can calculate the niche count, and then modified fitness value. So let us go to the next question. Next question is this is related to a mixed integer problem. So sometimes what we may have, okay, so suppose I have a problem, suppose I have a minimization of your x y. So what may happen, that one of the variable is integer your variable, that means it can take either 1 or 2 or 3 or 4, so it cannot take 1.5 or 1.6 or 1.7, something like that. So it cannot take, so it will take an integer value. Now question is that in R in NSGA to R, so whether I can use this mix, how basically I will solve this mixed integer problem. Okay, so this was the question. So the package we have used, actually there is no provision to use mixed integer or solve mixed integer problem. So in that case, what may happen? In that case, what may happen, that I can actually, for a particular variable, so I can define as an integer variable. So what will happen, this is a continuous variable, suppose this is 1.5. so once we can convert that particular variable to an integer variable using as integer. Okay, so using as integer, I can convert this particular variable to an integer variable. So what I will do basically, so I will modify my function, and there actually the variable, suppose in case of, suppose in this particular problem, suppose first variable is an integer variable. So in that case, what I can do, I can use actually for first variable, I will use as integer, and I will convert that particular variable to an integer variable. But if you are using MATLAB, so if you are using MATLAB, so MATLAB actually there is a inbuilt your provision for mixed integer problem. So what I can define, so what I can do basically, so I can define the integer value here, integer variable here, incon. Okay, so incon is a vector. So what you can do in incon, so there, suppose the first variable is your integer variable. So what you will do basically, so you will write in con equal to 1. Okay, or it is a basically vector. So now if you have suppose 10 variable, and out of 10, so in out of 10, suppose fourth and fifth variable is an integer variable. So what you can do, you can write in con. Okay, so in the vector you will write 4 and 5. Okay, so here you will write, so basically you are defining the fourth variable and fifth variable is an integer variable. So you can define that one. So that provision is there in case of MATLAB. So you can directly define an integer variable. So it's a mixed integer problem. All variables are not integer type. So only suppose one or two variables are integer type and others are continuous in nature. Okay, so that you can define. So let me take this particular example problem. So this function is something like that, this is a two variable function, and this is x and y. So the function is x minus 3.2 whole square plus y minus 5.2 whole square. So because I have taken this very simple function, it's a very simple function, because I know the solution here. The solution, once you are minimizing this particular function, the solution is x equal to 3.2 and y equal to 5.2. So it's an not integer your variable. So when you are considering that x is not integer and y is not integer, so in that case you should get this particular solution. Okay, so you should get this particular solution, and this is the MATLAB code I have shown here. So this is the MATLAB code I have shown here. And in con I have defined null, that means there is no integer variable here. So I have defined in con, but there is no integer variable, and therefore I am getting this particular solution. The solution is 3.2 and 5.2, and this is the solution, and function value is 0. It should be 0, but it is not 0 here, but it is very small number. Okay, so now let us define the one of the variable as an integer variable. Okay, so here what I am doing, I have defined that first variable as an integer variable. So I am writing in con, and I am defining as a vector. So in con, within bracket I am writing this is 1. That means the first variable is an integer variable. So I am defining here. So now you just see what solution you are getting. Solution you are getting 3 and 5.2. So because I have defined that x is an integer variable, that is the first variable is an integer variable. So now you are not getting 3.2. So earlier solution was 3.2 and 5.2. So you are not getting 3.2, but you are getting 3. Okay, so that is an integer value. So that is an integer value. Okay, so what I'm doing here, so I'm just defining that incon equal to 1. Okay, so you just define that incon equal to 1, and finally the first variable you are getting an integer variable. Okay, so that is the solution is there for 3 now. Now if I write that incon equal to 2, okay, so that means the second variable, that is the second variable, will be an integer variable. So here you are defining incon, and incon is 2 now. So therefore I am not getting 5.2. so earlier solution was 5.2, now I am getting 5 because that is an integer variable. So you are getting 5, and if I define incon, that means both the variables are integer in nature. That means first variable is also integer and second variable is also integer. Okay, so therefore in that case what I'm getting, the solution I'm getting 3 and 5. Okay, so because my x and y both are integer variable. So therefore in MATLAB this is quite easy to define a particular variable as an integer variable. So it is, you can easily solve a mixed integer problem. But in case of R, the package I have used, so that provision is not there. So what you have to do, you have to manually, or you have to define a particular variable as an integer variable when you are writing your objective function or the constraint function. Okay, so I hope this is clear to you. So we can easily handle or a integer variable or a mixed integer problem when you are solving your GA or when you are using genetic algorithm. Okay, now let us go to the next question. The question is, one student has asked that I have downloaded RStudio. This is RStudio download, so this is not sufficient. Okay, so RStudio 1.0.136. So this is so here what you have to do, you have to also download the R engine. Okay, so R engine you have to download along with the RStudio. So RStudio is basically the interface. Okay, so interface, and basically in the background, so you need R engine, so that you have to download. Now the next question is which optimization technique is used for minimization of error in machine learning application? Okay, so question is related to machine learning application. So I have not discussed any example problem of machine learning application, but here in case of when you are using your machine learning technique, suppose you are using artificial neural network. So in that case, what you have to do, you have to do error minimization. So there are several example problem of error minimization. Suppose you want to estimate some parameter. So in parameter estimation also we are using basically what we are minimizing that error. Now question is that what algorithm you should use this one. So let me explain this part. So explain this part. Suppose you would like to, you have defined an error function. So this is an error function E. So error function, suppose I can define, this is the actual value minus predicted value. Okay, actual value minus predicted value, or we are using, because it's an error, so we are using square, or what I can do basically, so I'm using absolute value between actual and predicted. Okay, so absolute value is also fine, or you can use the square of that one. Basically I would like to make it positive. Okay, so error should be positive, and this error I would like to minimize. Okay, so I would like to minimize this error. Now what is actual value? Actual value is basically, I can say actual value, but this is an observed value basically. So this is an observed value, or you can say this is the experimental results you are getting, or in some cases this will be the observed value that basically you have observed in the field. Now this predicted value is coming from the simulation model or simulation model. So what will happen, P is a function of several variables. Okay, so maybe your x1, x2, x3, okay, so xn. So now P is not directly coming. How you are getting this P is basically you are getting from a different function. So you are solving a different function. Now depending upon what type of function this is, so this error function behavior will be different. Now is that there is no freelance. So there is a theory called freelance theory, that I cannot tell that a particular algorithm will be basically useful for all types of problems. So there is no such your algorithm, something like that, that a particular algorithm will be applicable to all types of problem or all types of function. So therefore it is very difficult to tell actually which your algorithm you should use, but you have learned different optimization algorithm, such as, suppose I said that if you are using quadratic function, so in that case you go for your Newton's method, okay, or conjugate direction method. Now if your problem is a nonlinear non-convex problem and where you have more than one optimal solution, so in that case I say that you apply the meta-heuristic optimization algorithm like genetic algorithm or basically other meta-heuristic optimization methods. Okay, so therefore depending upon what function you are using, it's not that you are basically trying to minimize the error between actual and predicted value or observed and predicted value, but this predicted value is actually coming, and there is an inherent basically a function, and most of the time this function is a non-linear function. Okay, so therefore depending upon what type of function you have, so your algorithm behavior may be different. Okay, so you may have different your problem, and basically suppose you are using a quasi-Newton method, so for a particular error minimization problem, that your algorithm may be suitable, but if you are trying to solve this same problem, means suppose you are trying to solve a different problem using same algorithm, you may not get the similar result. Okay, so it's a problem specific depending upon what type of function. Okay, so when you are using suppose neural network, so I am not defining this function, but there is an inherent nonlinear function between the outcome of or what you are predicting from the neural network, or basically the what input you are giving to the network. Okay, so there is a hidden your nonlinear relation. Most of the time the relation is nonlinear. Okay, so therefore what type of relation you have, so you have to fix your algorithm. Now the second question is, I hope this is clear. I hope the first question is clear. So there is no universal you can say that your algorithm that will be applicable to all types of problem. So you have to basically select based on the nature of your function. Okay, so that you have to do. And the second question is that which are the other popular technique you must explore basically. So that was the question, and I discussed several algorithms, but anyway, so this is I could not discuss all the algorithms, but I said that there are other algorithms. Suppose these are some of the meta-heuristic optimization algorithms so that exist, and basically you can explore that one. And apart from that, in this course I didn't discuss some of the classical optimization technique also. Specifically there are other algorithms related to quasi-Newton method, so that I didn't discuss, so you may also explore that one. Then the another question is that what is your view on Python? Okay, so I have used R here. So R is also a very your sophisticated your software. So mainly it's a statistical software. So you but you can also use Python. Python is also equally very strong. Okay, so you can use Python certainly. So I have used R, but Python is also, I think all these functions are available in Python also, and basically so you can use that one. And so is it compulsory to learn? So I think you can take one of them. So you can use also MATLAB, but MATLAB, as I said, so you have to purchase these. You have to purchase MATLAB, but R and Python are free software, so you can download and you can use that one. So I will prefer that you use if you do not have MATLAB, then you use either R or Python. But Excel is basically, so you without any coding you can solve an optimization problem using Excel. And those who are not comfortable with coding, because once if you are using R or if you are using Python, so you have to have some knowledge, means suppose coding knowledge you should have. Then if you don't want to learn that one, or if you are suppose thinking that okay, I can I want to solve an optimization problem without doing any coding, so then you can solve, you can use Excel solver. So most of the problem suppose you can solve using Excel, but some complex problem you may not be able to solve. And Excel has some limitations, so it cannot take suppose whatever version we are getting, Excel solver version we are getting with MS Excel. So you can consider 100 variables. So if your problem has more than 100 variables, or if your problem has more than 100 constraints, so you will not be able to solve the problem. So otherwise, if your problem is a very simple one, suppose you have 10-15 variable and you have constraint of 10-15, so you can solve it. But some nonlinear problem you may not be you're able to solve using Excel. Otherwise, Excel is also a very powerful means suppose the toolbox Excel, that is so you can actually use for solving an optimization problem. Okay, so and how to rank it? So I will rank that, means suppose you can use R or Python. Okay, so that is I will rank in that way. But for smaller problem, okay, so you can also use Excel. So these are some of the question I have received. If there is any other question, then I can take, and I hope there is no question as of now. Okay, so there is no question. So this is the last live class. Okay, so this is the third and last live class of this particular your program. So now you have your exam, I think. So you go through whatever I have discussed in the class. So questions will be from that part only. You try to clear your concept, and already I have uploaded all the materials on the net. So you go through it, and your exam question will be from that part only. Okay, so whatever I have discussed in the class, it's fine. Okay, then as there is no question, so let us close this session here. So I wish I want to I wish you all the best for your upcoming exam, and thank you very much for taking this particular course, and I hope this will be useful. So if you want to go for higher studies, or I hope this program will be useful, or you will be able to solve the problem related to optimization method.